right, hello everybody. Welcome to our webinar today on Aivia 5 Neuron Exploration. It's our live launch. My name is Quinn and I will be doing the introduction. So our agenda today is we'll first do neuron tracing with a quick demo. We'll also take a look at our immersive data exploration, and along with having a demo with that also. We'll also do our neuron classification, and we'll have final remarks regarding packages, free upgrades, demos, and our DRV beta program. And then we'll end with a question and discussion session. So this is our team, and with me specifically today, starting all the way from the right, is Hoyen Lai, who is our product manager, and then Bryce Graft, who is a software engineer on our team, and then Luciano Lucas here, who is our executive vice president. Again, my name is Quinn Trand, and I'm the sales and marketing manager. And now I'm going to pass it off to Luciano to begin the presentation.
So before we go and get started, well, thank you very much, Quinn, for the introduction. But I wanted to give a very big thank you to the people that actually worked on building this this product that you're going to be seeing for the first time today. We have with us Bryce, who will do part of the demonstration later on today, together with Hoyen. John and Casey are on the software team, which is led by Tuan. Then we have Chi down here and his team that worked on the machine learning aspect of the package that I'm going to show you. Michael, who is our QA guy, and then the team that you already heard from Quinn a moment ago. Hoyen being the product manager, and Quinn is the marketing and sales manager. And we have Willie, who is going to be answering some of the questions directly on the live chat, who is doing our technical application support. So huge thank you, big effort, and I'm very, very happy to be the spokesperson for this group. DR Vision actually a bigger group of people, and maybe we'll have a moment to talk about that later. So DR Vision Technologies has been around for over, or this group of people have been working together for over 25 years in healthcare and also enabling science advancement. The brief history and background of DR Vision and the people that work here, they started together, a big group of them started together back in the late 80s, and they developed a machine that also had some software in it, and the company at the time was called Neopath, and the product that was developed was an automated pap smear device. It's still in use, and it's still the only FDA-approved device of this type. When that company was sold off, S-Vision was formed, which is essentially the same as we have right now, the same kind of a structure that we have right now. And later on in 2008, it was converted to DR Vision when Nikon became one of our investors. That was in 2008, and that's the format that we still have today. The company is about 25 people in total, and we do cover a wide range of applications. These are just some of the applications that we've covered over the years, and most of the work we do is developing software for other companies. But we also have our own product, and that's why you're here today. And so I will not spend too much time here, but a little bit about our background. We develop collaborations with academic researchers, and over the years we have been relatively successful at gaining grants and then developing good products that helped those scientists push their science forward, their projects forward. And this is just a sample of the projects that we've worked on over the years. Of course, we worked on the software development side and on the algorithm development side, not really on the biology side. But of course, it was a pleasure to do this kind of multidisciplinary work. Along the way, we created some new technology, and whenever that happens, we try to patent it. And we have a number of patents. I think now it's up to 50 patents. And the biggest group is in machine learning, and that's there's a variety of algorithms in there and workflows, but that's something that we'll touch on today as well. So that's one of the biggest groups of patents we have, but we have others in advanced search or in high-speed processing, and there's more information about them on our website. There's a link to the full patent description on our website if you're interested. Some of our collaborators, they're spread out a little bit all over the world, but mostly US and Japan. That's the biggest focus. And that's due to increase now that we're working on this product that we're launching today, Aivia. So to finish up on the introduction and background of the company, we do have three major areas where we operate. I already mentioned the contract software development. That's a big part of what we do. So actually the biggest part of what we do. We have recently started to offer image analysis as a service. So you can leverage from the best software. So we'll use any software that we can get, not just the one we develop here, but we might use any other software we might need. We have very good hardware where we can run the image analysis. And we have the very best team of people here that can help you get your job done. So it is, of course, very scalable, and it may even be the most cost-effective way to achieve the results you're looking for. And that's something we started about a month ago or a month and a half ago. And today we're launching Aivia, that used to be called, it's an evolution, I should say, of another product called SV Cell, and I'll talk a little bit more about that transition. But today's launch is of Aivia 5, and it's 5 because it has a history. It used to have a different name, but now that we're giving it a different set of features and we're bringing in much newer technology, we decided that it was the right time to rebrand it to Aivia. And this tool has 2D and 2D plus time applications, quite a lot of them. I think there's 14 different protocols, image analysis protocols of that type. And today we're launching 3 new major items, and they are neuron detection and editing, the immersive image visualization and interaction, and a machine learning powered cell classifier. So those are the 3 main things that we're launching today, but there's actually quite a lot more in Aivia 5 that is new. I think altogether there's more than 20 new features, a lot of them to do with reorganizing the GUI and making the workflows a lot smoother, and some improvements in performance as well versus the predecessor, which was called SV Cell. So for all of those that have been using SV Cell, they will now get Aivia 5 with all those improvements as well. So the first part of the actual presentation of Aivia 5 starts here. I'll talk initially about neuron analysis. It's an automated method which we have been working on the last 4 or 5 months. After that, I'll pass over to Bryce, who will introduce the immersive image exploration with the help of Hoyen, who will be doing the demonstration. And then it will come back to me to finish up with the classification tool, the cell classification tool at the very end. And then we'll finish up for today. I should say that today we're mostly focusing on what we are doing, what is possible with Aivia 5. we intend to have follow-up webinars and documentation that will show how we are doing things. And we hope that you will join us for those webinars in the future, where we'll show you what algorithms we're using, why we're using those, and what are the benefits. But that's not the focus of today. It's mostly the what. And we did that in this way because there is already a lot to talk about, and we don't want to keep you too long. So for today's scope is mostly about the what do we do. So the neuron analysis tool is fully automated, and you can see on the bottom hand side, on the bottom right hand side, what parameters you will need to put in order to get the protocol to run. I'll do a brief demo in a moment, but you can get pretty good tracing with the automated method. For editing, we have introduced something called the dendrite pencil, which allows you to draw very quickly in 3D space and get additional dendrites added to the traces that you already have. And you can also connect those dendrites to the network that you obtained automatically. There are a lot of parameters that we calculate for you, and if there's anything missing, please do let us know. We will work to add those in. Right now there's over 50 different parameters, but as I said, we can add more. The detection itself is very quick. This is one example. It's one of the examples we have on our website as well, and it's on our YouTube page, which I encourage you to follow. We'll be adding more things there. And on the data set with 1,500 pixels by 1,500 pixels by 500 slices, it takes about 25 seconds to run the image analysis protocol. And the results we find are pretty robust, but they're not 100% as with every algorithm. There's always limitations. And so we have added a tool that will, I mentioned already, the dendrite pencil, that will allow you to look at a data set that is already analyzed or semi-analyzed, and then you can add traces. And that's what I'm showing here in this brief video. So you can trace in 2D space, and the software will be measuring the intensity in Z and placing those spheres that you can see in the correct position in Z. And you can do that iteratively to either build a full network by hand, if you choose. There might be reasons for that, or to add traces that are missing on your original result. It is iterative, so you can just keep building, and it will keep adding to the dendrite that you're creating. And I'll show you this in a moment in the demonstration. In terms of rendering, or visualization of the results, we do have 3 modes, which may not be very apparent. This was a video, but unfortunately it's not showing right now. We do have 3 modes. One of them is a surface rendered mode to visualize the dendrites. We have another one which is a point and sphere, and another one which looks like a mesh, so it's transparent, and you can see the signal, the original signal, inside of that mesh. Inside the software, we also have a way to plot the results. Either it has histograms or scatter plots, and it's fully interactive, so it will connect. These dots that you see here are connected to a specific dendrite on the view and to a particular row on the spreadsheet. So with that, I think I'll go to the demo of the neuron analysis tool. But before I jump in, just give you a brief intro to the anatomy, or the where things are, because you might want to try it later on yourself. You can download the software from our website. Not yet, but you will later today. And this is what it looks like when it's open. So we have this panel on the bottom, which is a gallery view. Also allows you to do some manual measurements and do some edits. Then on the top center you have the major view, which could be a 2D viewer, a 3D viewer, a gallery view, and even it's also the place where you will see the note indicating that you are in VR. And then on the right hand side, top right hand side, you have the display settings, which will control the volume rendering, but also which detected objects you will show and how you will show them. I already mentioned for dendrites we have these three modes: the spheres, the surface rendering, and the mesh. That's also controlled here, as well as the colors of each object, the color coding. And on the bottom right is where you set up all the analysis protocols, and where you can also create the charts. Okay, so I will jump into Aivia. Okay. All right. Hopefully you will be able to see it. It's in the mode very much the same as what you saw in the PowerPoint a moment ago. This panel on the bottom is collapsible, as is the one on the right hand side. And that's very useful when you already have the results and you want to explore them on your flat screen. So you have more space to look at the results. That's why we have it this way, so you can collapse everything. As I mentioned, Aivia has a large number of protocols, and you can see them all here. These are all the ones that we have created, so we have many things from cell counting all the way to wound healing. But the one we're talking about today, and the one we've been developing over the last few months, is this one for 3D neuron analysis. So a data set like this is the one I mentioned earlier. We would need to set up some parameters, so the soma diameter, the dendrite diameter, the dendrite length in terms of the smallest branch you are likely to find, its intensity, and a mean offset. So those parameters, I will explain them in another webinar, in another occasion, so we have more time to discuss them in detail. But for today, we have it already set up in a way that is going to produce reasonable results. So I just started it now, and on a data set like this, if your computer is doing just this, it will take something like 25 seconds. Today, it's likely that it's going to take around 40 to 45 seconds, because we have many things hooked up to this computer right now. There's 2 webcams, we're streaming live, and so it's a little bit more resource deprived right now. So I don't know if there's any question I could answer right now. Is there anything?
Currently not any questions.
Nothing? Okay, good. So the rendering has, so the analysis has been completed, and now the rendering is happening, and it's already completed as well. So we can already start to explore the results. So let me show you. So that's the original or volume rendered image. And if I turn on the analysis that we've just completed, you can see it here. I'm going to change the coloring so that you can see the segments in different colors. And you can see now the segments here in different colors. Yeah, so that's what we would do to get the analysis done. Now, you will see that not everything is ideal. And so we can edit it, and I just wanted to show you that you can also you can see the parameters here. So these are the measurements for this data set. And if you select particular segments or particular dendrites, it will highlight them in the view. You can see it just highlighted that one on the top. If I select a different one, it selects a different one. If I select that one, it selects that one. So it's basically connected up here. So if I had a data set like this and I wanted to do some editing, we can go into this mode here called Neuron Editor, and you can select the pencil, dendrite pencil. can determine which diameter you want to draw at. I'm going to set it to 2.5, and then you can just simply draw. This is obviously too large, so I can just go back, set it a little smaller, and do it again. It's still too large. Maybe 1.2 is good. So I can draw like this, and this is drawn that segment in 3D space, and it ignored all that background that you see at the back of the image. You can draw a few other segments here, one here, here. Just going to draw all of these. Okay, and then I can connect them up simply using the connect button here. These are already connected. And that would be how you do dendrite editing. You can do this as long as you want. You can also draw from scratch. You already have a soma here, so you can start to draw from the soma out and build your own network. If you still have something, so I noticed there's still something still missing here, I can just draw the rest and connect these two, and now they are connected. Okay, like this. Yeah. Sorry, wrong one. Right here. Okay. So these are now connected. They are part of the same network, and that's how you do the editing. You can also, if you see something wrong, let's imagine that there is something wrong here, you can delete a point. Just simply select the delete, select the point, hit delete, and it's now two separate segments. One over here and one over here. You can also connect segments that are not. That's what I was doing earlier. So you can just click, drag, drop, and then it's one single segment. So I think that's it in terms of the demonstration for the neuron detection and the neuron editing. I will move over, give my chair to Bryce. He's going to come and talk about the VR aspect of Aivia. So Bryce, I welcome you back on your chair.
Hello. Okay. Make sure volume's good. Okay, I'm Bryce. I'm a software developer at Deer Vision Technologies, and we're going to give you a quick overview of VR. And so some of it might be review for you if you're already familiar with VR, but just be patient. It's pretty cool technology. Okay, so VR turns a room into a completely custom environment, and it makes it so the user can move around and interact seamlessly, walk around anywhere they want to in the room. You can move your head down, up, and completely look around. It's a supernatural way to interact with 3D data. People sometimes struggle with interacting with 3D data, and that's why there's special professions that focus on things like 3D modeling and etc. But VR is quickly becoming invaluable over every single discipline. Entertainment is usually the discipline that starts something like this. Then it moves on to training, and surgery simulation is an example of a really critical thing that's happening now. Education and learning, you're seeing augmented reality as well with that. But for virtual reality, research is why you're here potentially. And we'll show you what we have here. Okay, so a typical VR space, you can actually use a VR space when just kind of standing in a small space, but it's not ideal. you typically want a 6x6 foot room. This room right here, it's not actually that big. It's about 6x6 for our space, which is perfect. And you have these units called lighthouses that are mounted on opposite ends of the room, and I'll talk about those in a little bit. And the result is being able to walk and move anywhere in the space, and you're motion tracked. So we're going to talk about the Vive. Currently, Aivia supports the Vive. Oculus Sport, hopefully coming soon. So the VR headsets are currently at 90 hertz or 90 frames per second. And to get a really smooth experience, you need to have a high frame rate like that. So your typical TV and computer monitors are at 60 hertz, which if you were to wear a headset at 60 hertz, it would not be a smooth experience. And everything is kind of moving to 120 hertz. So per eyeball, it's about a 1080 by 1200 resolution, which is pretty high. Eventually, it's going to be more like 4K per eyeball, which will be ideal. It's finally to the point where you can forget that you're looking at a screen and just kind of immerse yourself in the environment. That resolution's high enough for you to forget you're looking at pixels. So the panels that they use for VR headsets are OLED, and what that means is it's extremely high contrast, which is at better contrast than most TVs. Some are OLED now, and phones are moving to OLED as well. And so that kind of makes you forget your suspension of disbelief that you're in this other world. Each screen has a 110-degree field of view, meaning your eye can see that far, and that's a very natural field of view. And so each eye, how it works is with the screens, each eye is rendered in parallax, and you can set the distance of eyes because everybody has a different eye parallax. So right now, you're currently wired to the computer. There's a kind of a trail that falls behind you with VR. There was a wireless solution, but it sold out instantly, and that will soon be the norm. But for now, there's a trail that follows you with the Vive and Oculus. It's unfortunate, but that's the way it is right now. Okay, so I'm going to go over the controllers right quick. Can you hand me that controller? Thank you. Okay, so this is the Vive controller. These are motion tracked in 3D space, which is pretty neat. And they're rendered in the environment. So when you're inside the environment, you see the controller. If you've seen demos, you've seen that before. There's a trigger on the back side. There's a D-pad on the front, and it's touch sensitive, meaning it knows the exact position of your thumb. And there's a grip button on the back side right here, and we do use that. These are so accurately motion tracked that one of the demos had somebody wearing a headset so they couldn't see anything. Their buddy threw this controller at them, and they were able to catch this controller in midair with a headset on, because this is rendered when you're inside the view, which I thought was pretty cool. Okay, so the motion tracking, this is kind of the magic that makes VR possible, aside from the pixel density on the screen. So these things called lighthouses are on opposite sides of the room. I'm going to show you a quick video right here. Okay, so this right here is a lighthouse, and it projects infrared light, and this is a sweep of infrared right here. So this sweep of infrared will hit the Vive controller and headset, and as you see right here, this little guy's headset's lighting up. And what it's hitting is there's light emitting, these are diodes right here. They're photosensitive diodes for infrared. So that's what gives the Vive its golf ball-like appearance when you see this big headset, and it kind of looks like a golf ball. And what it results in is the disparity, the difference between the position of all of these different diodes makes it so we can find the exact location of where you're at in that space. And that makes for a really seamless experience, because it's just completely natural. As soon as you move your hand here, it's tracked so accurately, it completely fools you, which is amazing. So we've also tried giving VR to people who have never used it before, and in 5 minutes they can instantly and naturally manipulate objects and move around, and they're having a great time. And it's kind of fun to watch somebody use VR for the very first time, because it's kind of a transcending experience. I'm not exaggerating. It's always really fun to watch someone use it for the first time. So I was going to play a little bit more of that video. So yeah, basically the alternating lighthouses sweep across the room, and then they hit exactly on the controller and headset. So a lot of people see VR, but they don't know how that works. So I wanted to make sure we went over that. Okay, so I'm going to go over the controls in Aivia really quick. So one of the major controls you're going to be using is scaling a scene big and small. So you can pinch in with your Vive controllers. Can you hand me the other controller? Thanks. Plug in Hawaiian over here. Okay, so you can pinch in with your controllers, and that will make the scene smaller. You can pinch out. You hold the triggers as you do that, and it makes the scene larger. And to move around in a scene, you're obviously motion tracked, so we know exactly where you're at. So you can just walk around the scene, go anywhere you want, look any direction you want to. But you can also, if you need to move around the scene, since 6 by 6 foot is not like an unlimited space, you can hold both triggers and move the controllers relative with each other, and that will just translate your position just as if you walk somewhere. Some games do something where you leap forward. It's not as natural unless you have an actual floor. So for D-pad, we have that map to moving and translating yourself in the scene, so we know exactly where your thumb's at on this pad. It's also a way to move around. Okay, so one of the coolest things you can do is move objects, and this is the most natural thing that people jump to VR to do is by reaching out with your controller, holding a trigger down, and moving the object around. And as you're holding the trigger, the object moves with you. That's one of the most fun things in VR, because you're just manipulating objects naturally. And then lastly, we have the little grip buttons, which aren't as commonly used, but we just use those to reset the scene. Let's say you've moved every object around, and you say, I want it back to the original position where my neurons are originally, and that'll just reset the scene. So I think we're gonna do a demo with Hawaiian. So let me give you a brief intermission here. 1 second.
Okay, so we're back to Aivia. This is the same data set that we had previously already analyzed, and for now I'll leave it with these settings. So you can see it's displayed with the sphere. Hawaiian is already has the headset there in the background. I'm going to move from the 3D view that we have right now. I'm going to move to the VR view, which is just on the top, and you'll notice that the screen changes. Here it will say to put the VR headset on. Hawaiian is already there, ready to go, and I'll be changing the mode that you can, so that you can see this. You can see also what Hawaiian is looking at. Okay, so this is that big neuron that we were looking at a moment ago. It's really easy to control the scene. With the two little Vive controllers, you can zoom in. That's what Hawaiian is doing right now. You can zoom in and go very, very close to the cell. You can bring it towards you using the two controllers, or you can move it away, moving the two controllers. Also with the two controls, you can basically pan, move the whole thing to the right, move the whole thing to the left. And Hawaiian is getting really, really close to the soma there. Is actually now inside the soma. And I'm going to just change a setting here on the soma rendering, I'm going to make it solid. So now it is inside of the soma, and all of those points you see are the starting points for the dendrites, those semi-transparent spheres, all of those. And that's pretty neat. Actually, it's a lot of fun to explore data sets like this. I'm going to change now the settings for the display from sphere to surface, and this is with the surface rendered. Actually, this is a mesh right now, so I'll change it here to a surface, and each segment has its own color, and that's the easiest way to look at how correct a dendrite is in terms of tracing. But for exploration, it's nicer actually to see this all in one color per cell. So I can color this one whole cell in one single color. So one of the things we can do, and it's pretty unique to Aivia, is the possibility to interact with individual objects. If, for example, we wanted to compare objects that are very far away from each other, and you can just see now Hoyen picked one dendrite in one location and another dendrite from a different location, and he can bring them close to each other and compare their morphology. Right now we can do this for dendrites, but in the very near future we'll be able to do this also for whole cells. So we'll be able to just basically pick a whole cell from one location, let's say in a big brain piece of tissue. You will have cells that are very far away from each other normally on the data set, but you may want to compare them side by side in VR, so you can just pick them from one location, pick another one from another location, and bring them right next to you, and you can look at them in VR. I don't know if it's apparent, but you can actually walk around, and Hoyen is kind of walking around slowly now. You can walk around, go above and below the data set, and we intend to make many more interactions possible, like editing and tracing in VR as well. And that's going to come in the next months. So I think that's maybe it for today. We already did one webinar 3 weeks ago where we did only VR, and so it was a little bit longer, and we actually have it on our YouTube page and on our website. So if you want to view that one, there's a little bit more detail, and the demonstration is a little longer too. We have a few more data sets that we showcased it. So I think we're good. Thank you very much, Hoyen. So I'll just take a moment here to go from the VR to the next part. So just take a few seconds. I'll be muted to adjust a few things here. Okay, we're all set. So the next part is the neuron classification, and for this we've used one of the many ways, one of the many algorithms related to machine learning, and this is something we have a lot of experience here at DR Vision, not only with the patents, but there's a lot of other work that we've done over the decades in this area, and we have a lot of products deployed that have some sort of machine learning in it, either guided or not guided. We have some pixel classifiers and a few other things. But for today and for this application, what we've developed here is a neuron classifier. So to get to the next step. What we've used is a particular type of an ensemble machine learning method for classification. We picked one that is very robust and high performance, means it has low error and runs very quickly. Because there is a need, of course, for analyzed data sets, we went to a very well-established reference, the repository of reconstructions. It's the neuromorpho.org webpage, which holds thousands of neuron reconstructions. And we used a sample of those reconstructions to train 3 classifiers, one for human, one for rat, and one for mouse. All of those classifiers that we've created using the neuromorpho data are fully open and free. They will be available on our website to download for everybody. And on the software, so in Aivia, you'll be able to not only apply a classifier that already exists, like the 3 that we've created, but we'll be able to augment the ones we have created. So you can take, for example, imagine you're working with mouse neurons. You can take the mouse neuron classifier that we've created using the neuromorpho data pool. You can augment it with additional examples from your research, and then you can apply that classifier on other data sets. And we'll give you a measure of accuracy per class and also for the whole classifier. For the classifiers that we have built, the 3 that we have built, we made sure that we're not overfitting, and we did quite a bit of testing to make sure that that's not happening. And one of the methods we used was k-fold cross-validation. You probably need to do something similar. If you need any help with this kind of validation, we can help you as well. If you're using Aivia and you create your own classifiers, you need some help to make sure they are good, we can help with that. As a rule of thumb, we always used 9 or more cell examples, and it's really better to have around 50. From around 50 cell examples, the classifiers tend to be really robust. And typically it's not necessary to go as high as 100 cells. So it's pretty small number considering the results that you can get. It's a very small number of cells that you need to use. So the workflow, how it works is you can, first of all, you have to detect the neurons, and you can use Aivia to do that, or you can use other tools. There are quite a few other very good tools out there. So once you have the detection done in Aivia or in a different tool, you can, if it's in Aivia, of course, you already have the reconstruction in the software. Then what you do is you go to the part of the software where you do the classification, and you can basically assign, by clicking on the cells, assign each cell to a particular type. You do that for a few examples, and once you're done with this, you hit the button that teaches. And at that moment, the classification or the classifier is built, and it will also give you a measure of accuracy, the likely accuracy for each class, and also for the whole classifier. You can save that off to use later, or to send to a colleague, for example, or to augment later if you want to add more examples, because you may be working over many days. So you may add some examples today, some more examples tomorrow, and you can continually add and basically make the classifier even more accurate. Once you have a classifier, either one of the ones we are shipping or the ones you create afresh, you can then apply that classifier to a new data set that has reconstructions, and you may want to know how many cells in that data set are of a particular type, and that creates, once you apply, it creates subgroups for each type of cell. So the classifiers that we've created, I mentioned we made one for human, one for rat, and one for mouse. There should be some text here saying mouse and rat and human, but this is what we have. So the human one has 4 cell types, and I have a little bit more detail in the next slide. We used a total of 101 cells, and we reached the overall accuracy of 95%. That's what you can expect when you run this, is that 95% of the time you're going to get those 4 cell types correctly assigned. For the mouse, we have 6 cell types. We use 287 cells to teach, and we can reach 98% accuracy. And for the rat, 6 cell types as well, and 354 cells were used to do that, and 93% accuracy. So this is a little bit more detail, and you can see here which cell types we have taught on, and they are slightly different because the data pool is still not very complete, especially for human. There's only 4. We only have 4 types, and even for a few of those types, so for stellate and granule type neurons, there are only 5 examples available. So we've used all 5, and with the stellate also there's 7 examples, so we used all 7. But overall, very few examples of neurons for human. Not so for rats and mice. So we have a lot more cells in each of the classifiers, which should mean they are more robust than the human one. But still, we felt that the human one is going to be robust enough to be usable. So what kind of applications can you do with this classifier? The obvious one, or the one that we talked about so far, is just classifying different neurons. You have a sample with many neurons in it. They may be different types, and you can apply this classifier so that it tells you which types you have and how many cells you have of each type. You may also have a different study where you have just one type of neuron, but there are subclasses of that neuron. Maybe there's something different about them. So you can teach based on your experience to create subclasses. You may also have a different phenotype due to an intervention that was done, a treatment, for example, or some sort of intervention that you've added to that animal, and then it may change something on the phenotype of the cell type that you're looking at. Or it may be to do with developmental stages. So maybe you have developmental stages and you want to see how the neurons evolve over time for a particular type. So that's just some examples of what you could do. Of course, you can also look at disease versus non-disease states. That's also a likely application. So in that case, you take the non-disease state, teach based on those examples, teach based on the disease state neurons, and then you could present the software with a sample that you don't know if it comes from a patient or from somebody healthy. You can apply it, and it will tell you already if there are already any cells in there that are likely to be from a patient. That might be an indication of a disease that is at early stage, for example, and that you would otherwise not spot. We can import a standard file already, which is the SWC. This is the most commonly seen neuron reconstruction file. And very soon we'll be also able to load IV and VRML files. So this will cover pretty much 100% of the reconstructions that exist out there. But SWC is a great way to start too. So this is how it looks when the classifier is open in Aivia. You have this panel here that shows all the neurons that are available for classification. And below here are all the classes that are already loaded. And down below you will see there's these multiple tabs, and each tab indicates a class. So in this case I have already applied a classifier. I've applied a classifier, one of the ones we pre-taught, And once I apply a classifier, I get all of these tabs down here, and the cells can also be color coded based on the class that they belong to. So I think now I'll go into Aivia to show you how to do this very briefly. We have here, I've loaded a data set with multiple neurons. You can see it here. It has really a big mixture of neurons of different types. And I don't need this panel anymore, so I can close it so we have more space for visualizing the neurons. And they are mixed. I haven't applied yet the classifier to this, so that's the typical situation. You'd have lots of neurons in one cell, in one sample. So to start the classifier, there is a tab or a button on the top here that will open it, and it will show me all of the neurons that are in this data set. So you can see them. These are just thumbnails that indicate there is a neuron there. There's 10 of them, and they have not been assigned right now yet. So I could create a new, at this stage I can either create a new classifier or I can apply an existing classifier. And as I mentioned, we offer you 3 classifiers out of the box, and they are here. You can select through them, and I could, if I wanted to, augment one of these, or I can just create a new one. So to augment one, I would pick the one I'm interested in. I would then click on a cell like this one and drop it into the appropriate group. I can also select it from the view, so I can select this cell, and it should show me which cell it is from the top. So it's neuron 7. The one I just selected here is neuron 7, and I can now drop neuron 7 into the appropriate group. That's something I can do. Or from the thumbnails that are being generated, I can also see what type it is. If I'm an expert in this field, I can see what type it is, and I can just pick it up and drop it into the right class. That's how you would create a classifier. Once you have all the cells in the correct classes, you then hit the button down here that says teach. That's how we'd create one. And if we have a bit of time, I'll probably still do that. But now I wanted to show you how to how to apply an existing classifier. So we have these 3. I've picked the one for mouse neuron classifier, and I will apply it. And what you will see, and I'll open it so you see it. So right now there are no objects down here, no tabs. That means there are no subgroups created yet. But once I hit this button, the classifier that we have pre-taught will be applied on these images that are here on these neurons, and as a result there will be multiple tabs down here. This is in the spreadsheet zone. So if I apply it, you can now see there all of these are visible, and I just need to make sure these are on so that the measurements are on, and those are being calculated. So there we go. So we have here the measurements for each of the dendrites for each of the classes. So if I go into each of these, I should have measurements. Okay, so here, for example, the motor neuron type or the granule type, that looks like there's only one granule. There are 1, 2, 3, 4, 5 motor neurons. So it has already done that classification for me, and I can color the dendrites by class. And you can see now, if I zoom out, seems like a lot of them are of the same type. There's 2 types there, or 3 types, and there's one more on the bottom. So that's another type. That's for sure a Purkinje cell. Yeah, that's one, which is the one here. So that's how you would apply a classifier. You can then, of course, explore the data even further by exporting it to Excel, and you can look at the parameters for all of the objects that are of a particular class. And in this demonstration, the classes are just types of neurons, but classes could be anything, as I mentioned in my in the slide that I was showing you earlier. In here, you could use as inspiration. These are some ideas for applications, but you could do many other applications. In the near future, probably in a couple of weeks or 2 or 3 weeks, we will do another presentation where we will be focusing on how we are doing the machine learning, or what kind of machine learning algorithm we've used, how it differs from others, and the benefits of using it. But you're very welcome to start testing the classifiers that we've created. So we're pretty much running to the very end of our planned presentation for today. Just wanted to summarize, and in the meantime the guys are joining me as well. So Aivia 5 has a fast neuron detection, has also editing tools for neurons. We have launched an immersive data exploration solution, which Bryce and Hoyen showed you earlier. The machine learning cell classification is something that I just showed you now. We have also video animation export, which I haven't shown you, and there's a lot of other improvements versus SVCell, which was the prior product, which I didn't talk about today because I guess for most of you it's the first time you hear about DR Vision, and for sure the first time you see Aivia live. So for you it's not an improvement, it's just as it is. Aivia 5 we will offer a free upgrade to everybody that has SVCell right now. So if you have an SVCell version, you will get Aivia 5 with all the benefits for the same functionality that you ordered your SVCell. So if you had SVCell with all the recipes, you will keep exactly the same recipes. If you want to add the 3D neuron analysis or the VR or the classifier, please do contact us, and we can provide you with pricing and licensing information. The demo file will be available, or the demo software will be available later today. I don't know if it's already on the website. I think it's not, but it will be later today. It is? Mm-hmm. It is already. You can already download it. So you can already go to our website and download the Aivia 5. And I wanted to mention also we have DRV beta. This is a closed beta program. It is now full. It actually became full within 3 days of us launching it. We were looking for 10 people to join it. We actually got 19 people to join, and we're very happy. This group of people will help us develop the software over the coming months and the coming years. We're planning next webinar on machine learning and 3D neuron detection, so please join those. We will put information on our Twitter, and our LinkedIn, and on our website, of course, so you can follow there. Our website address is DRV Technologies. That's drvtechnologies.com. And if you go there, you can download the software right now. We do have many ways to provide you the software. It's very modular. We have a number of packages, and the pricing is very flexible too. And I also wanted to mention we have a very special token for the launch. There's 10 of them available, and you're the first ones to get them probably. So if you go to the website now, go to the Aivia 5 page, so the drvtechnologies.com/Aivia 5. On the top of the page, there is a way to create a token, which gives you an enormous discount on the product. So yeah, I'd recommend it. Okay, so I think we're down to the very last slide. I think we have received a few questions. Yeah, we have received a few questions. So I think the guys will join me. Just a moment. Let me adjust here the settings. We're back.
All right, hello everybody. We're back. So we're at the questions and discussion section. So a couple of questions that came in is the first is what kind of measurements do we detect in the software?
Well, there's a huge range. I mentioned there's about 50 just for the neuron part, and the measurements would be what you would expect. So dendrite length, diameter, tortuosity, number of branches, this kind of thing. But on the other recipes, the measurements will be related to the recipe or to the protocol that that you're running. So if it's cell tracking, for example, it will be speed and length of track, how many tracks, how many corners, is it a straight track, is it bending, things like that. So it varies a lot between each recipe, and there's a huge number. And if there's anything missing, this is one of the easier things to do is add measurements. So if there's anything that you see is missing, do let us know. We can add it.
There's also user programmable.
That's a good point. Yeah, maybe you want
to. We have a system where you can make your own measurements by using basic functions, and you can make complicated measurements if you need to by chaining those functions. And it has IntelliSense, and it works pretty well. So you can generally get what you need to get when you're trying to measure something. So that's it.
All right, so for Bryce, one of the questions, especially since we demonstrated a very short demo here specifically with the neurons, there was a question coming in about the types of data that can be viewed in VR.
Oh, so we mostly focused on the neuron aspect of it, but you can do volume rendering in VR. We haven't really focused on for this release, but any type of surface you want to render, once you've made, we don't really talk about it either, but even if you don't have neuron data, if you just want to make meshes and thresholds to render in VR, you're able to do that. And with those objects, you can still move them around just the same as the neuron objects. As long as you can import it into our software, which we support everything we can, you're able to render what you see in 3D and VR. And the only thing you can't do right now is we're not focused on the tools. Some of the more advanced tools we don't allow in VR. It's just for viewing and manipulating, moving around the data. One cool thing that we didn't mention in VR, and you kind of saw it, is you can change the display settings on the other side, or if you have a friend at a workstation, whoever or partner you're working with, they can change settings, view settings, and it changes on the VR headset. And you can obviously view that on the VR mirror on the main machine. So I hope that helps.
Yeah, no, that's great. Another thing, while you're also speaking, especially when it comes to the VR component, and I think Luciana, you had mentioned it, is I wanted to talk a little bit more because I think it's a really cool aspect, and especially when you're collaborating, it really showcases a lot of what you can do. I wanted to talk a little bit about the Keyframe Animations part that we have, and because I think it's a cool component.
So, just like if you're in video editing, you can do keyframes, which you can have a perspective. Maybe we could just show a little bit of it. If you want to render a video, for example, a demo video of your data moving around, you can save a particular position and you can transition anywhere in the scene. And the cool part is we support exporting Avi Files, so you can export a nice YouTube video of your scene. The YouTube videos that we make, that's what we use, or we can use as well, for some of our stuff internally. Mm-hmm. But it's a really cool tool to collaborate. Do we want to demo that?
Yeah, if you want to go, so if you go to our website at drvtechnologies.com/Aivia, so you will see on the big backdrop there is a video that is of a neuron that has multicolors. And then and that video is actually generated using our Keyframe Animation tool. And what the really cool thing is that what you see on the what you see on the display is what you're going to get as the result of your export. So you can export it with heat map settings. You can export the volume. You can export the mesh, and all that view through a fly-through, and it's really awesome.
Okay, another VR question. Because a lot of potential researchers might want to use VR but not necessarily have the hardware, what are kind of the, what do you suggest for the VR? And also, I did want to mention that we will, as part of our packages, be offering the VR hardware also.
Okay, so for VR systems, you don't actually have to make the most expensive system to run VR. Obviously, we'll say you should have the best hardware you can. Personally, the cost, I built a machine from scratch, every single component for my wife, and it runs VR, and it was $800 for that machine. There's GPU-wise, I would recommend at least a NVIDIA 1060 GTX. There's a major advancement in those cards that render almost twice as fast as the previous generation for VR. And I think on our website we have our recommended specs for that. So the main thing is obviously your GPU, but it is taxing on every component. So an i7, like this demo machine isn't even, it's running a 3570 i7, I believe, which is previous generations. It's not even the most updated, and it runs VR just fine. So check our website, but the main thing is your GPU, very up-to-date GPU, and the card I just recommended is about $250. So it's not the most expensive card. So that's it.
Okay, we also have a few questions on the classifier. One of which is, will the machine learning cell classification work on both the 2D and the 3D data? Because what you demonstrated here, Luciano, was a set of 3D data.
Yeah, it should work. We haven't really done any detailed testing on 2D data sets, but the technology that we have here can be used for 2D data too. So if you have an application in 2D, please get in touch with us, and we will test it for you before we tell you to just try it yourself. We've been very, very focused on the 3D neuron story, and that's why our effort went in there. But the machine learning tool itself could classify other objects.
So that is all of the questions that we have gotten so far. So thank you everybody for coming. If you have additional questions, please feel free to put those questions into our website in the contact information, and you can also email me. I will be sending out a thank you email after this webinar, so feel free to just reply back to my email with any additional questions that you have.
I'd like to thank everybody for attending, and I'd like to invite you to join our Twitter, LinkedIn, and YouTube. Especially on Twitter, we're very, very active, so you'll get to see a lot of our work. And some fun things that we get to do sometimes. It's a pleasure for me to have you all here, and I saw some people in the registration that I know for a long time, so thank you very much for attending. I hope you enjoyed it. If it's the first time that you attend one of our webinars, you're very welcome, and I will hope to see you again many more times. We'll be hosting webinars regularly, probably every 2 to 3 weeks. We'll be doing one. So thank you again for joining,
Thank
and
you.
See you soon.
Bye-bye.